today, the goal of today's webinar is really how to build out larger scale, medium scale to larger scale VDI deployments. And we're going to discuss both from the compute side of things and from the virtualization software from the VMware side of things, as well as from the storage side of things. And really, how do we actually go and implement these VDI projects? Because the longest running joke in the industry, of course, is the year of the VDI. And really, this presentation, the goal is to how do we logistically actually build these things out. So my name is Garrett Clark. I'm the VDI architect here at SolidFire. I've been at SolidFire for right around 4 years. And first we're going to start with the VMware piece, and I'd like to introduce Tristan Todd from the end user computing piece within VMware. So Tristan?
Thanks very much, Garrett. This is Tristan Todd with the EUC team at VMware. I'm a reference architect and kind of a passionate EUC guy, and yes, this is the year of VDI. You are correct, sir.
And with this presentation, guys, I would say it's one of those, with a lot of webinars, of course everyone kind of watches it, plays solitaire on the back end and so on. But please be interactive. We have the chat piece right there. After each set of slides, we'll be reviewing and answering questions. We'll try to make jokes, try to make it funny along the way, and keep everyone engaged. So thanks. Fire away, Tristan.
Okay, well, thanks very much to Team SolidFire and Garrett for letting me talk a little bit about what I think are important storage attributes of kind of a winning solution for large-scale VDI. And at the top of the session, we talked about the kind of a long-standing joke about this year being the year of VDI. And on the next slide, we actually depict kind of our UC solution stack. And you'll notice that Horizon View, kind of the lighter blue section in the middle there, is the core desktop and application delivery technology from VMware that sits on top of vSphere. But we have a lot of other things. For instance, we've got Identity Manager, which used to be called Workspace. We have App Volumes. We have User Environment Manager. And then we have Flex and Mirage. And so we're starting to build a more complete mobility solution for enterprises, and VDI is just one component. My belief is that you'll see less and less VDI as we go forward in large enterprises, large organizations, and to see more app delivery and more data delivery, because users at the end of the day are really interested in their apps and their data. They don't necessarily want a desktop. However, some use cases like financial services and healthcare are always going to gravitate towards VDI as a delivery mechanism. So next slide. So one of the challenges with VDI is just how many things, how many I/O activities, how many data operations occur in the life of a desktop. From initial deployment, day zero activity, to first login, to every Monday morning login storms, maintenance, upgrades, and the like. All of these things have a different I/O pattern and I/O attribute. And they also have some capacity restrictions and attributes as well. So this makes VDI kind of challenging at a very large scale. It's very hard to deliver a winning solution when you've got all these things happening and you're thinking in traditional terms when it comes to storage. Next slide. So if we build this out, Garrett, you'll see that in years past we've recommended to our customers that you segregate your storage. You actually deploy tiered storage for all the different components in your environment. That could be your master replica for a clone pool. It could be your app stacks in a different storage platform. Your swap file could live somewhere else. And all of these components generally have different I/O patterns. So I've just kind of depicted a generic I/O pattern here for these different components. You can see some of the things like link clones themselves are very bursty. Pool replica is very bursty, but generally only reads and during the initial startup process. So if you click once, Garrett, you'll see that when all of these things overlap, you've got a very good opportunity for a noisy neighbor phenomenon. So with I/O patterns, and these are just general I/O patterns, when you have bursts that don't overlap, when you have bursts that do overlap, when you've got steady state, mid-range type of consumption, in a large environment, getting to that getting to that winning solution, that winning design can be challenging with traditional storage that is more bound by I/O. Next slide. And so what we've done in the past is we've recommended that servers and desktops never mix, and we actually recommend tiering out the storage for desktops. So individual components of the desktops, your apps, the desktops themselves, user data and things like that, segregated. But we also have recommended segregation of use cases. So different types of users, different type of use cases may have different data requirements, different storage requirements, depending on the type of desktop, depending on the type of use case. So they lend themselves to hybrid storage solutions, traditional storage solutions, and all flash. Next slide. So what I've talked about, and you can click through here, Garrett. What I've talked about is all flash solutions because of their advanced capacity management capabilities with things like data reduction and deduplication, and their ability to handle lots of I/O bursts, lots of noisy neighbors cohabitating in the same storage environment. You can actually mix your workloads. So your graphic designers, your WebSphere developers, your offshore temp workers can all live happily in the same storage environment. And typically, the storage environment itself can handle the disparate heterogeneous workloads more than traditional storage. So it's really changing our best practices from a storage perspective. Next slide. So I'll offer up a few tips that apply to considering a large environment, considering if you have a goal of deploying a winning solution and kind of encouraging VDI use through happy users and good user experience. So our first recommendation to customers is do an assessment when you're evaluating an existing VDI environment or a physical desktop environment. It's really critical to actually assess the environment. We have a free assessment offering called the SysTrack Desktop Assessment. I'll talk a little bit more about how you gain access to this. But basically it's an agent-driven model where you deploy some agents on existing desktops, and it actually goes out and evaluates the different use cases, gives you information like what cloud storage is in use. Next slide, Garrett. I've just grabbed some screenshots here to show the SysTrack Desktop Assessment does go out and look at reads and writes. It looks at latency. It looks at what applications are consuming the most I/O. It'll tell you who your noisiest users are. It'll actually help group your users by storage utilization patterns. So it's an absolutely essential process to go through to assess your workload before you actually arrive at a design architecture. Next slide. And to get started, you can go to assessment.vmware.com, and I think there's a build out there, Garrett, but you basically register for the program. You download some agents on your desktops, physical or virtual, and then you let it percolate for a couple of weeks at a minimum, and then you get some detailed reports. And some of our partners, like Lakeside, have a really cool integration with Lakeside. It's called a marketplace integration. And effectively what you do is you can start with a free assessment. You can talk to Lakeside about doing a full Lakeside SysTrack assessment and then bringing in a marketplace integration from a vendor like SolidFire. It'll actually take all of the storage inputs and then map it really, really nicely to the current platform offerings, the storage offerings from a company like SolidFire. So basically it'll take your environment, it'll take all of your observed utilization patterns and then map it to give you an idea of sizing, give you an idea of scalability. And it's really, really slick. And it's just, these are the kinds of integrations that we think customers should glom onto because they will shorten the time it takes to get from assessment to implementation to happy users. Next slide. So I'll let you kind of follow my voice here, Garrett. But we recommend that whenever you do a large-scale deployment, you deploy some tools, things like VRealize operations for Horizon, tools that will give you an idea of the underlying vSphere utilization, things like PC over IP latency. It allows you to actually set dynamic thresholds and get a really good idea of what user experience means to you users. A tool like VRealize Log Insight, this is a way that you can actually gather unstructured data from things like syslog and get really good stats on things like latency. In this screen grab, I'm just showing some latency at the host level. And so this is a kind of a better than ESX top method to get an idea of if you're experiencing latency. Full alerting and reporting, of course, available with this product, but I think Log Insight is one of my new favorite tools. Unstructured data logs and feeds like syslog are just invaluable if you're doing troubleshooting or performance analysis. We've got some partner solutions as well. Lakeside, their SysTrack tool, after you've actually converted to VDI, it's a great tool for evaluating your environment. In this case, we're showing utilization patterns. Periodically, we're showing kind of the busiest days of the week, the busiest days of the month. Really, really critical to understand your environment, understand what your peak average resource consumption patterns are. That helps you decide, make good decisions about scalability. Next slide. We've got a long history with Liquidware Labs, their Stratusphere Fit product. It's basically an offering that fits into VRealize Operations Manager and gives you very, very good user experience dashboards. Color-coded, of course, green is good, yellow a little bit concerning, orange you probably better take a deeper look. But it gives you an idea of how quickly applications are launched, what the user login times, things like that. It really gives you detailed statistics. So for an operations center, a desktop support team can look at this dashboard in the morning and get an idea of how healthy the environment is, and it's much, much more proactive than waiting for the phone to ring on the service desk. Next slide. So vendors, and I'll pick on SolidFire a little bit, but storage vendors these days, and there's a whole bunch of them and a whole bunch of really good ones. But IOPS numbers are thrown out as kind of a big hero number, something that we really like to discuss when we're trying to sell all-flash storage and hybrid storage solutions, even solutions like VirtualSAN from VMware. We really fixate on IOPS. But what I want to articulate is IOPS, speed is really important. But you have to consider the other aspects. It's not just the back-end storage IOPS, the back-end storage capability that you want to look at when you're looking at storage. You also want to consider the full virtual disk round-trip latency. Next slide. And by that I mean go ahead and pay attention in ESX top terms, in vSphere terms, into guest average, the full round-trip latency. It's really important that we recognize we need good back-end storage performance. We need low latency. We need a high IOPS capability and burst capability. But we have to consider other things in the architecture like the storage network, your HBAs, and even your kernel loading, how busy your kernel is if you have any queuing occur. So it's really important to use tools like ESX Top, VRops, to go ahead and look at the entire picture. Don't fixate on IOPS. Remember, you're serving up a virtual disk for a user, and you want to make sure that that virtual disk is low latency with minimal queuing. So next slide. So we consider users as kind of prima donnas, and I myself, I don't interact with a spinning hard drive any longer. My son, who's 13 years old, he really has never in his life interacted with a 7200 RPM drive. So he is a VDI, or excuse me, a low latency storage aficionado. And so we really believe that we should architect VDI systems and designs that don't just deliver the 7200 RPM experience. We think that our VDI users deserve the best storage, and that means the storage that can give them the all-flash, the low latency experience that they enjoy on their tablets and sometimes on their home PC. So when you consider best storage, a partner of mine and I came up with this kind of crazy acronym for how to evaluate storage. So you can go ahead and build this slide out, Garrett. The idea is to take scalability, performance, availability, manageability, and simplicity, what I call SPAMs, into consideration. Next slide. So if you look at all of the storage categories out there, and I've kind of broken up all the Nouveau storage solutions into 6 categories, you arrive very quickly at the determination that, next slide, or just one click, Garrett, that all flash arrays really have kind of the best spams measurement. They scale really well. The performance is obviously best in class. High availability, easy to manage, and simple as far as a component in the architecture. And so my advice to people who are trying to arrive at a award-winning solution for VDI scenarios is to really look at all flash as kind of the best option right now for all the categories of storage. And I wouldn't be a good VMware employee if I didn't say Virtualized is awesome. However, I still consider shared storage and particularly all flash arrays as kind of the best choice when you look at all the categories out there. So with that, I'm going to turn it over to Garrett and let him talk to you about SolidFire and what they're doing in the field of VDI to help you succeed and win over your users.
Cool, appreciate that. To this point, for the folks that are on the phone, let's pause for 15 seconds. Are there any questions in particular about the VMware side of things? Yeah, please put it into either chat or the questions bubble. Okay, sounds good. We'll keep jumping in. So really, if you look at SolidFire and in particular our VDI story, one of the biggest challenges that folks in particular see just in general with VDI is one of the biggest barriers to VDI is kind of twofold. The first one being performance. If the performance of your VDI deployment run in the SAN architecture isn't as fast, if not faster, than you running it on your individual laptop, in a lot of circumstances that becomes a pretty big barrier to having it happen. The second major piece is the cost. And we'll talk about how SolidFire does global inline efficiencies to really get that cost down, to really eliminate that barrier. The second piece is that with the folks, and as Tristan had alluded to with the scale out piece, is one of the biggest challenges that folks run into VDI if it's been implemented, in particular in the very, very large scale, is most folks typically start at a pilot level, grow to production, then they grow to that massive scale. Then from there, the key here is that we have to have that first VM have the same performance as the last VM. Then from here, performance control, where we can start this VDI project. How do we get this started? Or how can we run multiple VDI projects all in the same system? And then the last piece is a largely automated and simplified architecture. Goal here is that we want to have the management of this VDI infrastructure be as automated and as simple as possible. So let's jump into first and talk about efficiencies and talk about cost. So SolidFire SolidFire has global inline efficiencies, global inline deduplication, compression, and thin provisioning done across the entire cluster. And on a scale-out basis, this can lead to very, very significant efficiency gains as it pertains to the cost perspective. So this graph here on the right is showing the number of VMs, and then this column on the left is showing the number of the VMs, and then the row on the top is showing the divergence per VM. So from here, this kind of gets the light bulb to go off as if we have 50 VMs, each one of those VMs is 50% different, then our deduplication is 6.0x. And where this becomes pertinent is as we scale the system out and as we grow the system out, typically those VMs become more and more similar as we get larger and larger scales because there's been more instances involved. So from here, how that pertains to particular cost as it pertains to dollar per desktop is as we grow out this environment, subsequently that dollar per gig cost goes down, and then from there also it becomes more and more economical. Okay, any questions on that from the phone? Okay. So jumping on into the scale-out architecture. One of the additional challenges is how do we grow an implementation from a larger pilot piece, but then from there, then it grows to a medium scale to large scale to et cetera, et cetera. We solve that through this scale-out architecture where we can incrementally add these new nodes to the system and really grow that out to each one of those individual pieces. Then from there, to show you guys kind of what this looks like underneath the covers and from a cost savings perspective. So we can add these new nodes in. It automatically redistributes the data, automatically load balances all of those pieces are done completely under the covers. So we have 3 separate node types, the 2405, the 4805, and the 9605 on the system. Reason why this becomes very important is one of the challenges is once you get to a larger scale VDI deployment, the key is well, do we need to add more capacity or do we need to add more performance to it? And we don't really know whether we need to add one or the other until 2 years or 3 years down the road. With this type of a node-based architecture, what we can do is if we need more performance, we add a more performance-centric node to the system, and it will automatically rebalance it accordingly. If we need more capacity, then we add a more capacity-centric node to the system, and again, it'll rebalance it accordingly. What can also be kind of interesting here from a DR perspective is we can take out nodes, and then these nodes could potentially be our DR for a different site. So we can mix and match these different node types. We can mix and match between different drive vendors, and we can remove the nodes from the system. What's kind of cool here, and this will be a very interesting selling point down the road, is the price of SSD in particular is dropping at a very dramatic rate. And different vendors from an SSD perspective have continued to control the market in different manners. So from here, for example, we had originally come out with the 3010 and the 6010, and we're just talking relative cost, kind of $1 desktop per nodes and just list price. And first into the market, we had come out with Intel drives. Then from there, we came out with Samsung drives. We looked at the market, decided that Samsung was starting to become the market leader, so we came out with the SF9010 that uses Samsung drives. Then the 2405 and the 4805 also use some Samsung drives. And our latest model, the 9605, runs on SanDisk drives. Reason why that becomes so important is we've been able to drop that price dramatically in a relatively short period of time. So from a cost benefit perspective, let's just talk about the cost benefit of scale out compared to scale up. So let's say, for example, we have 1,000 desktops per year growth, and let's assume that then we need 4,000 desktops at the end of 4 years. Okay? And let's just assume a $50 per desktop cost just because it's a good round number and it's easy for the math. So in a traditional system, right, you purchase that storage for the larger scale up front, and then we have an annuitized cost that's much higher. Whereas if instead we purchase the desktops only as we need them and subsequently take advantage of that 20% year-over-year price decline, there's a significant decrease in the amount of cost for the overall system. So you can kind of see a pretty graph right there, and in this instance right here, it just saves just north of 25% over the course of 4 years. So on the chat, from the questions perspective, are there any questions on that? Oh, great question. Yeah, so the number of nodes that we can scale out to. So the smallest config that we would have is 4 node based, and we'll talk about that particularly within the HA section. Then from there, we can scale out. The largest tested is 100 just because we kind of had to draw the line somewhere. But from there, most VDI deployments typically stop at about 20 to 30, so it's all in the same rack. And it's done in more of a pod-based design. Cool. Okay, any additional questions? Or I guess we can jump on. Cool. So the second piece here that Tristan had alluded to, which is a very big challenge within VDI, is the challenge is that the VDI workloads are very inconsistent in nature. So because of that, the best practice from numerous vendors is to dedicate out a storage array to each individual VDI instance, or dedicate a storage array out to VDI as opposed to your other databases and other pieces within your infrastructure, just because of the inconsistencies of performance. Now, what we can see here is this is our classic quote-unquote noisy neighbor effect that we see. So we have a VDI deployment with 1,000 seats, and it goes through a boot store. Then subsequently, you can see where it affects, in this instance right here, a database, and that database performance goes through the floor. Whereas with us right here, subsequently, we've seen if we increase that min IOPS to 20,000, then from there you can see that this particular database runs on a flat workload, and then the VDI deployment, again, gets the IOPS that it needs. So reason is that this becomes such a huge deal is that best practice is to dedicate an array for VDI because VDI performance is very unpredictable, which kind of blows up our economic story. So what we can do on a system like SolidFire with the ability to set and provision those performance levels that we had seen in the past 2 slides is, one, you can purchase the array for other applications, possibly your databases, et cetera, Then from here, then we can essentially get VDI for quote unquote free, where we can use the remaining capacity on the system. Then from there, QoS settings accordingly, and be able to build out that pilot, test it out, validate it prior to moving it into the larger scale pieces. Or then the flip side is let's say that we purchased the array for VDI. The challenge here is that deduplication rates are inconsistent, right? You might get 5x, 10x, 20x, et cetera, et cetera. So what we can do is either one, we can spec this conservatively, and then we likely only use a half or a quarter of the capacity, but then you can get that additional capacity and use it for other applications or use cases. Or the second piece of there is we can spec it based upon an average, and then from there, then with the scale-out architecture, you can add additional nodes as needed based upon your current deduplication rates. So that's something, I know it's definitely a very different concept compared to what most storage vendors and most implementations typically are associated with. But that said, it's something that with VDI that can become pretty critical. The next piece that I would say can become pretty critical as well is the shared nothing high availability. And if you look at VDI, so much of VDI is largely centered around automation. And really, how do we build this out? How do we scale it without necessarily needing to scale headcount in a comparable manner? With this shared nothing high availability, this enables us to do that. So on the left here, we have a traditional system with dual controllers, shelves behind. Then from there, the challenge is if we lose one of these two controllers, we got to rush into the data center. Second major challenge is we lose one of these shelves, well, then we have data unavailability. So the idea around a shared nothing HA scheme is to have the resiliency across each one of these individual, in our case, nodes, and then self-heal the system around it. So let's show you what this looks like. So let's say that we unplug one of these nodes. This would be the apparent of losing a controller or shelf, depending upon how you look at it. The system's automatically going to self-heal without any manual intervention. So really, it's an automated HA scheme. And the reason why that becomes so important is the comparison needs to be made in between a self-healing architecture and a 4-hour next business day support based architecture. So then from there, the key is that rebuild process happens immediately rather than waiting for 4 hours or next business day dependent upon your support. Other very interesting piece here is the many-to-many rebuild process. So in this instance right here with 7 nodes, we're looking at less than 60 minutes for a full node rebuild, and those rates increase as we scale. So as we go from a 5 node to a 10 node, et cetera, your HA story gets that much better. And it really eliminates the need for those fire drill recoveries. Right here, it's showing the comparison in between a 5 node cluster, a 10 node cluster, compare that to an all SSD system versus a tiered system as it pertains to the rebuild process. So any questions on that, guys? Cool. Let's jump ahead. So the final piece here, just to kind of fill out a couple of these pieces on here, is that on a traditional storage system, the key here is how can we make this as simplistic as possible to manage. So in a traditional storage system, these are instances and these are things you have to think about or do on a day-to-day basis, right? As it pertains to your RAID type, RAID group, what drives are you using, your data migration strategy potentially, aggregate assignments. Let's talk about controller upgrades or replacement, the drive shelves required, et cetera, et cetera. So very difficult from a management perspective compared to that, whereas on SolidFire, that system is entirely automated. So the key here is that less time that you use, subsequently that accelerates your business as much as possible. Cool. So the last piece here is how each of these various different integrations and tie-ins from a vCenter plugin, PowerShell, et cetera, each one of those make it so that you really don't need to manage the SolidFire system. It can all be run through VMware. Things like VAI, things like VASA, things like QoS, SIOC, which becomes very interesting from the performance control pieces, SRM, et cetera, and looking forward into vVols, where on vVols, then we can subsequently set those QoS settings on the per vVol basis. So I guess just to summarize this thing out, one, costs really get down because of that global inline deduplication. From the scale-out architecture, we really have that ability to grow from a pilot to production to full scale to ensure that that first VM gets the same performance as the last. The performance control, which enables us to start that VDI pilot for free, and of course the automated architecture that makes it as simple as possible to use. So from there, that's the end of the presentation, but let's just open it up for a variety of different questions and kind of make this more of a generalized discussion.
Hey Garrett, this is Tristan. I'll start it up. So with your sure nothing and high availability feature and you know the I guess a very automated recovery and the fact that I don't have to go through I think what you call the fire drill. Do I have to back up my data any longer? I mean,
yeah, I mean, you certainly could, but I would say that would be something that, it really changes the dynamics of it as it pertains to that particular piece. I mean, just because it's, backups, recoveries, et cetera, there's so much time that's spent into that, and I would say to a large extent that really kind of goes away.
Okay, and then another question I had, I tend to consider all flash storage like SolidFire as kind of tier 0, tier 1. It's where my desktop, certainly my critical desktop should live. But things like user data, persona information, the thousands of PowerPoint files that I might have stashed somewhere. Do you recommend that customers, put their data on a SolidFire system, that kind of data, what we would consider tier 2 or tier 3?
Yep.
Or would you recommend using something inexpensive, Equilogic or Isilon, something low performance but fairly good at just handling lots of data? Yeah,
because the repeatability and the dedupe associated with it, the key is that you can actually put each one of those pieces on there rather than needing to segment it out. With something like VDI in particular, because everyone has the same programs, very similar if not identical files involved, and each one of those types of pieces you could actually put it all on the same storage array.
Nice, super cool. Okay, that answers my question. Thanks.
Thank you. Sounds good. I guess that's all that we have particular for questions. Really appreciate the time and appreciate the folks that had joined. For more information, of course, our website is open, and we'll be having each one of these webinars on various different topics going forward. So yeah, appreciate the time, everyone, and thanks for attending. Bye-bye.